Hi everyone. In this lesson we're going to look at how to calculate the range of a projectile. So we have a particle here at ground level. It's been fired at a speed u with an angle of elevation theta. Now that will follow a nice parabolic arc through the air and land over here somewhere. I'm assuming the ground is horizontal and I'm assuming that there's no air friction. So the way to approach this question is to divide into horizontal and vertical motion. So I'll label this ux, the starting speed in the horizontal direction, and this will be uy. Now as the thing flies through the air, we will have to consider horizontal and vertical separately. So let's make two lists. For horizontal, we have ux, vx, ax, displacement, and time. Now time doesn't get a subscripted x because time is not a vector. It's only the vectors that get split into horizontal and vertical. Now I'll say that this equals the starting speed by the cosine of the angle. I don't know the final speed. I can say that acceleration is 0 in the horizontal direction because there's no air friction. I don't know the horizontal displacement, but that's what I'm interested in. That is the range of the projectile, and I don't know the time of flight. Now let's think about the vertical part of the motion. So once again we have u, v, a, s, and again t is not a vector, time is a scalar. So do we know the starting vertical component? Yes we do. That's the speed multiplied by the sine of the angle. We don't know the finishing speed for the vertical. We do know acceleration is downwards and it's at the value of 9.8, but I'm going to write g to represent 9.8. I do know this one. If we think about that for a moment, vertically the particle starts at ground level, it finishes at ground level. So there is no upwards or downwards movement between the start and the finish, and time is unknown. Now, I've got knowledge of 3 of these things, but I only have knowledge of 2 things over here on the horizontal side. So there's more information on the vertical side. Let's start with that one. And I'll start with the formula S equals U T plus 1/2 times A times T squared. And we'll substitute 0. I'm just going to leave this as uy at the moment, times T minus G over 2 times T squared. I'm trying to solve for time. I could do this in a couple of ways. The best way is to take a common factor of T and now I can use the null factor law. So T could equal 0, which would represent the starting point of the motion. Not a very interesting solution. Or we could have that uy subtract g over 2 times t could equal 0. This is more interesting. Uy could equal g over 2 times t. So 2 times uy divided by g could equal t. That's the one I'm interested in because that represents the time of flight, the time that it takes for the particle to come back down and hit the ground. So I will reject that solution as not very interesting. Now, let's come over to the horizontal part. So horizontally speaking, I'm interested in the range of the projectile. So I'll use the same formula. Now, this is 0 because the horizontal acceleration is 0. So the formula is quite straightforward. The range of the projectile is ux multiplied by the time of flight. And the time of flight is down there. It is 2 times uy divided by g. I'll just move the 2 to the front. Now, what was ux? That was u multiplied by cosine of theta. And what was uy? That was u by the sine of theta. Still divided by g. So I'll write this a little bit more neatly now. That would be u squared multiplied by 2 times the sine of theta times the cosine of theta over g. Now, there's a formula in mathematics that says this part here, 2 times the sine of theta times the cosine of theta, is the same as 2 times, as the sine of 2 times theta. Now that's my formula for the range of the projectile. If I know that we're on horizontal ground, if I know that there is no air friction, I need the starting speed, u, and the angle of elevation, and I need the strength of the gravity. And that will tell me how far the projectile flies. Interestingly, for a given speed, u, and a given value of gravity, so if those two are fixed, if the only thing that we change is theta, then the best or the maximum range, will be when the sine of 2 theta is the greatest, and the greatest that could be is +1. Remember, sine of angles goes from +1 to -1 only. I'm saying if u and g were fixed and we're only changing the angle, so 2 times theta, now the sine of 90 degrees is 1, which means that theta would be 45 degrees. If you launch a projectile at a 45-degree angle, that will make it go the farthest it can for a fixed speed of projection. Okay, that's all for now. Thanks for watching.